Hello everybody. So today we will do some exercise on filtration. We will do two exercises. So this is the first question where there is a constant pressure and a compressible cake operation occurring, and the second one will be a plate and press filtration equipment. So on that filtration equipment, we are going to determine the washing time and also the final volume of filtrate collected or the optimum cycle time. So we will do these two exercises. Yeah, first we will do question number one. So here it says laboratory filtration conducted at a constant pressure drop on a slurry of calcium carbonate in water gave the data shown in the following table. So this is the data given. The filter has an area of this much centimeter square, and the mass of solid per unit volume of filtrate was this much, and the viscosity of the fluid is given. Then you are asked to find the specific cake resistance, but the operation given here is constant pressure and compressible cake. So here is the data. This is the volume in meter cube. This is not liter actually, it's meter cube. This is in meter cube, and the time is given in seconds. So for different uh, pressure drops, you will have a different time given for delta P1, delta P2, delta P3. Therefore, for this operation which has a constant pressure and compressible cake, for constant pressure and compressible cakes, so we know that the general equation for filtration can be represented with this equation, where this alpha is cake resistance and Rm is the medium resistance. This is the area, the viscosity of the fluid, and delta P. So here the pressure is constant, and since the cake is compressible, alpha will be changing with the changing pressure. Therefore, with this relation, alpha will be alpha naught times delta P to the power of S. S means the compressibility coefficient. So this compressibility coefficient and alpha have to be substituted here in the the basic filtration equation. So when you substitute this value here, then finally you will find such equation. dt over dv will be this equation. So this value is some constant plus another constant. So you can put it as dt over dv will be kpv plus b. Kp means here you put kp, the value of kp will be this one, and b will be, which is related with the Rm, the BDM resistance, that will be this one. So finally, you'll have T over V will be Kp times V plus B. So if you draw the graph of T over V versus V, or time over volume versus the volume collected, then you will find different slopes for each delta P, for each pressure change. So this different slopes, the slope will be Kp. So from this Kp, you determine the alpha naught, and from this Kp, alpha naught and compressibility coefficient can be determined, and from the intercept, you can determine the filter medium. So you will have different Kp values for different delta P's. Therefore, you have to calculate the you have to take the logarithm of this Kp equation and change it into a linear equation. So from this, you will find that y is equal to mx plus b, which is a linear equation, can be produced. So if you draw the logarithm graph of Kp versus delta p, ln Kp versus ln delta p, you will find such kind of line, So from this line will give you a negative slope. From this negative slope, the slope of the line, which is 1 minus s, you will find the value of S, or the value of compressibility coefficient. And from the y-intercept, you will find the alpha naught. Alpha naught can be determined, or the initial cake resistance can be determined. So if you know these values, then here is the volume we have here, and the time per sec is given. So you have to determine T over V for each delta piece. Let's say delta P1. P1 represents delta P1, P2 delta P2, and P3, delta P3, and P4. So for each delta P, you have to determine what T over V. So here for delta P1, which is 0.5 bar, T will be 17 divided by 0.5. So if you do the same for all, delta, if you do the same for T over V, then you will find this equation here. So finally, you will find this data. So for each delta P, when you divide T over V, you will find this data. So if you draw the graph of V versus all this, if you select this and insert, then this, you will find this data. So this, then you can put the equation on them. For example, for this one, for the first P1, which is P1 versus V, you will add equation. So just add equation on chart. So you will get this equation. Then for this one also, you can add. So when you draw P versus KP, so for example, for P, which is 0.45 bar, 1.1 bar, 1.95, 2.5, 2.5, and 3.4. Then K will be for P1, this is P1, K, which is the slope, will be 13.261. For P2 will be, for P2, K2 will be 7.5507. Then for P3, it will be 4.4961. Then 3.765 and 2.96. Then you can take the logarithm of P and the logarithm of K. So this will be ln of P. You find this value, you can do the same here, and also the same for K. Then you can just do it like this. So if you draw the graph like this, you will find such kind. So you will find this equation. So this is your slope. The slope will be used to find 1 minus s, or the compressibility coefficient, and this one, the intercept, which is 2.18, will be used to determine the alpha. So when you put your data here, this is your filtration data, then this is your P versus KP data, then next one, this is your log K versus log P data. From this you can determine, so the slope is 0 minus 0.752, which is 1 minus s, so s will be 0.248. So the compressibility coefficient will be, for this operation, 0.248. The intercept, here the intercept is 8.925. So the intercept, which is 8.925, will be mu times alpha times v over 2a square root. So this alpha will be calculated by using this equation. When you substitute all these value, you can determine the value of alpha.